Okay, another integration by parts problem. So this is what we're going to do next. Evaluate this integral. When I first saw this problem, I didn't like it at all. I didn't remember a whole lot about ln x, and I just couldn't even visualize this. When you see something that you can't create an image in your head with, don't let your brain go to mush. Just go to Desmos. Go to Desmos and type in the different functions and then multiply them together, and you'll get graphs of what they look like. And here this is the graph of the square root of x, this is the square of ln x, and here they are multiplied together. And this sort of goes like this. It's kind of a cute function, but there's nothing weird about this. It's very straightforward. And so, yeah, if it begins to look like gobbledygook to you when you see these terms, go to Desmos. The other thing I want to say is I'm on this subject is also don't go into these problems without knowing what the answer is or having access to the answer. If it's not in the back of the book, get an app and go to an app and find it out. The answer is not going to give you any hints about how to do the problem. You're going to have to do the problem. And the beauty of these problems is that it gets you to look inside of the functions and gain a fluency with the way they act. And if you don't get the right answer, you're going to go back and see where did you trip up. So be sure to have the answers with you. So here is my problem here. Back to ln x. I don't remember anything about ln x, but I did make myself a table, which you can download from the notes. And when I see a problem like this, my first instinct is to make x my u. But I don't know anything about ln x. I don't remember if it's in my integral table. I don't know whether I can find the integral of this. So I don't know if it can be my dv. So I'm going to look, and in fact I can. Except the v would be x ln x minus x. And you know what? I don't know if I want to play with that. So I'm going to just see if I can maybe use it as my du. As my u, I mean. And yes, look. ln x is in my u is under the u's, and my du would be 1 over x. And I'd much rather play with that. So I'm going to try that out and see what happens. Okay, at this point I do know what happens, but at the time I didn't. So I've said that I'm going to make my u ln x, and my du, I just found out, is 1 over x. My dv then is going to be square root of x, which I'm probably better for me to think about it as x to the 1/2. So my v is going to be x to the 1/2 plus 1 would be 3/2. And so this would be 2 over 3. There we go, 2 over 3. Okay, now I'm going to get rid of this because sometimes that confuses me because I don't need it now. So u is ln x times v, 2x to the 3/2 over 2 divided by 3 minus the integral of v to x to the 3/2 over 3 times du 1x dx. Okay, actually this looks like it's going to work out pretty fast. Yeah, so ln x, 2x to the 3/2, and I should put this first, but I'll get to it. Minus, I'm going to pull out the 2/3, And I'm left with x to the 3 halves over 3. No, over x dx. And I can simplify this. I can simplify this to this is how I'm going to do it. I'm going to do my little cloud thing. This is equivalence in my brain. I can think of this as the integral of my exponent rules are 3 halves minus, and this is the same as 2 over 2. 2 over 2, so that's 1 half. X to the 1 half dx. Oh, which I've already done. So this is great. Okay, so here we go. Is 2x to the 3 halves ln x over 3 minus the integral of this, which actually don't forget the 2/3, which I actually know already is this. So 2x to the 3 halves over 3 plus c. We're done. We can simplify further, which is nice because it actually looks like it'd be fun to simplify. 2x to the 3 halves ln x over 3 minus 4x to the 3 halves over 9. Is it right? 4x to 3x over 9 plus c. And then let's do this. I could make this into a 9 and this into a 6. And then I can do that plus c, and looks like I can factor out a 2x to the 3 halves. That would be 3 ln x minus 2 over 9 plus c. That's it.